Hey guys, you're on Quadratic Functions crash course. This is what everything you need to know in order to succeed with quadratic functions and succeed on your exams. So I primarily consider this as for GCSE iGCSE students, and this is the quick recap and revision, but actually I'm gonna say that pretty detailed. And also, if you are A-level student or IB student, that's also you might find very useful because you can pick up lots of information that might be lost from your previous study. Okay, so anyway, let's grab your pen, grab your notes, and let's get started. So first of all, I want to clarify the term quadratic expression because your function is based on quadratic expression. So first of all, remember that bx plus c is simply a linear expression because x stays in the power 1. So b and c some coefficients. So if you add on top of that quadratic term like x squared, you'll get exactly quadratic expression. And that's what makes your function, if you equate to another variable, y from x, because obviously this expression is dependent on x, so that's why you just denote as y from x. So here you can consider as quadratic function. It's not the relation, so actually you need to know the difference between relation and function. In this case, we consider it as the function because for every single value for x, you'll get single value for y, and that what it means you have the function. In case of relation, you will have several y's. So in this case, you have a function, and in the case for 1x, you might have several y's, let's say y1 and y2 for a given x1 value. In this case, you'll have relation. So we are going to consider quadratic function exactly as the function, not the relation. So I just simply eliminate relation because we're not going to consider, and because quadratic function is the function and not relation by definition. Okay, so I'll show you later how to differ that and show exactly why parabola and quadratic function is exactly the function. Okay, let's go next. So what you need to know in order to be successful with different sort of questions. So you need to know how to sketch the graph, and in this case, as for straight line, you need to know the behavior of the function. Here you need to have the same knowledge about what actually you need to keep track of, like what sort of specific points, and also you need to understand the general behavior. Okay, so that's why for any parabola should look like the U shape. So for example, relating to our case, your parabola should look like U shape. So that's U shape, and those parts we can say that they are branches of our parabola. So in this case, branches up, and as you can see, this function or this curve has the minimum point. So this is the minimum point. If you have another type of function, another type of parabola, it might have branches down. In this case, you'll have the maximum point. Above this point, you cannot see the graph, and that means this is the absolute value, maximum value for the function. Okay, as well as for the green one, this is the minimum one. Okay, so but in both cases, it's U shapes and it has branches. So branches of the parabola. So this graph, it's called parabola. Okay, but this is like general stuff. What about details? What about points that are really critical in order to determine the behavior of the parabola? So first of all, we need to understand how to find x-intercepts. X-intercept as for the straight line, the same point when your graph, when your function crosses the x-axis. So that's why it's called x-intercept. In case the parabola crosses the x-axis, for example, if we consider that one, which is green, we can highlight those points. So they are called x-intercept or x-intercepts. So in this case, we have 2 points of interception. But the general condition where we can pick x-intercept is simply you see that when the parabola crosses the x-axis, in this case, y function, y value is equal to 0, because have a look, those points are at the level when the x-axis goes, it means that it goes at the level for y equals 0. This is sort of ground level. In this case, y is 0, so that's why the condition to find x-intercept, conditions to find x-intercept simply equate your y to 0. So that's why generally you will have ax squared plus bx plus c equals 0. Okay, let's say that we have an equation. Let's take any equation, absolutely any. Let's take this one. Y equals x squared plus 3x and plus 2. So conditions to find x-intercept, simply we equate y to 0. So that's why your quadratic expression x squared plus 3x and plus 2, we need to equate to 0. So that's why we arrange quadratic equation right now. So this is quadratic equation. How to solve that? To find those x's, we need to, in our first case, use the formula, which is called quadratic formula. So quadratic formula that tells you that x values 1 and 2 can be found as minus b plus minus square root of b squared minus 4ac and over 2a. So you can memorize this formula. I'm not going to prove why is it so. So you can have a separate video where actually I was showing that. So please check it out. It will be in the description below. However, this is the general case. So in our case, we need to determine coefficients. So in our case, coefficient a is simply coefficient before x squared. So in this case, a equals 1. Not 0, be careful, because if you had 0, you would have actually x squared times 0, which is 0 term. It means it doesn't exist. However, you have x squared, so that's why it's 1. Next one, 3x, it means b is 3. And what about c? c is 2. Okay, those coefficients you can use in the formula in order to find out the roots. And let's just find it quick. So x, 1 and 2 equal to minus 3 plus minus, let's calculate what stays here in under the square root. So this stuff, it's called discriminant, and it actually tells you very interesting. It actually gives you an idea what sort of parabola you'll have. I'll explain in a minute. Right now, just let's grab the numbers and let's calculate. So b squared is 9 squared, and minus 4ac means minus 8. You'll have square root of 9 minus 8, which is simply 1, and over 2a. So that's why finally you'll have minus 3 plus minus 1 over 2. In this case, you'll get x1 equals Let's take first with the plus. Minus 3 plus 1, you'll get minus 2 over 2 is negative 1. And the second root, when you use minus, in this case you'll get minus 3 minus 1 over 2, you'll get minus 4, and over 2 minus 2. So that means we found x and y intercept. So that's why we can use them to plug, so not to plug, but to depict on the graph. So for a while we just fixed those values. We fixed them up. And we'll go to applying the next approach. This is alternative way instead of using quadratic formula, using factorization. So let's try to factorize. So we have x squared plus 3x plus 2, and you need to factorize that. Just remember how to solve quadratic equations. So the way I prefer is x plus a and x plus b equals to 0. And now you try and pretend that you would like to expand this expression. So you'll get a times b here in the end. Then you'll have x by x is x squared. Then you have xb and ax, so you'll get ax and plus bx. So that's what you'll have if you expand it. If you expand. And to show you the way how you can do this. So the result is 0. Here in this group you can factorize x, and hence you'll get x squared plus a plus b times x and plus ab. And now you just need to compare this expression, which is general, because your way is to having those factors equate each factor to 0, because that's by definition when the product is 0, each factor might possibly be 0. So that's why your possible solution is first x plus a equals 0, so x1 is negative a, and also you might have x2 equals to negative b. So right now your goal is to find a and b, and let's try to do it right now. So have a look here. You have a plus b is coefficient before x, so you can write down your expression and you can compare that AB product is going to be 2, so AB is 2, and the sum a plus b is going to be a coefficient before x, so that's why a plus b is going to be 3. From where are you trying to guess? So please guess the value for a and b. That's how you can find them. So guess. So just try to pick up integers, because in this simple expression they definitely should be integers. What I would say that a is 1 and b is 2, for example. They might be actually swapped, like a is 2, b is 1, but it doesn't matter, because you have absolutely symmetrical expression like x plus a, x plus b, you can swap them, it doesn't matter actually. So, and let's check the second one. So 1 plus 2 will also give you 3, so that's why a is 1, b is 2. So this is the general approach. Actually I show why is that so, why eligible to do that. So, but you need to memorize that the product a and b, so to recap how to use it practically, of course you're not going to expand every time, right? So you just simply do what? You take in the product, AB, and the result should be 2. And then you take then the sum A and B, and the sum should be equal to the coefficient before x, which is 3, from where you find solution. So that's a solution for A and B, but finally your solution for x is going to be the same numbers but with the opposite sign. So x1 is -1 and x2 is actually -2. So that's, as you can see, that fits to what we found using quadratic formula. So that's why we found generally, let's have a look what actually we found. We found Xintercept because right now we explore how to find Xintercept for any function. In this case, the function is x squared plus 3x plus 2. So this is the general scope, and that's how we're looking for it. So what we can say that here is actually the sketch for this Cartesian plane. I just copied that. So just move away. So right now what we are going to do, using Xintercept, we fixed those 2 points, and that's how we know where parabola cross the x-axis. So we've got both -1 and -2, so that's why we need to add a little bit extra. So I just add the rest part here, because we have them both negative. Actually, I think that I need to redraw this one, because I need to have more space right now. Set up here. Yeah, that will be good. So, and now what I'm going to do, I'm just going to extend a little bit to have values that we get -1 and -2. Let's say here, and here as well. Just I extend a little bit to get more units. And so what I know that -1, which is here, and -2, which is here, represent our x-intercept. So that's how it works. Our parabola goes through those points. If you like, I actually can mark them. So let's mark them for a while. So this is minus, this is -2, and this is -1. And definitely we know that parabola will cross x-axis in those points. Okay, red points are those x-intercepts. So we found x-intercept. We put them on Cartesian plane, on graph, in order to draw the function curve. And the next step is to find y-intercept. Okay, so we have the equation x squared plus 3x plus 2. You remember what y-intercept means. Let's go back to general idea of what function is and where actually y-intercept occur. So y-intercept is where your parabola crossing, let's say, x-axis, then cross definitely y-axis. So this is the point where x equals 0. You understand why? Because if the parabola goes through y-axis, it crosses somewhere, and the x-coordinate of any point where the parabola crosses the y-axis should be x equals 0. So this point should have the coordinate x equals 0 definitely. So that's why we can set up the next condition in order to find y-intercept. So we found x-intercept, that's the procedure, and we go next and try to find conditions for, we actually found conditions for y-intercept, and now we clearly state. So conditions for finding y-intercept. So now y-intercept. How to find y-intercept? We just recently heard that we need to say that x is going to be 0. So in our case, x squared plus 3x plus 2, this is our function, equals to y, and we plug x equals 0. So we definitely need to find y from 0 for our function. Y from 0, everywhere we plug, where x stays, we plug 0, and we'll get 2, because 0 plus 0 plus 2. Okay, so that's why we have y-intercept exactly in point y equals 2. So that's why we just go to the graph and we'll say that, let it be this color chosen for y-intercept, and this is 2, so it's here. This is y-intercept, and we can drop the value 2. Okay, so now we understand that our parabola goes somehow, because it's U-shape, it definitely should go somehow like this and cross the y-axis and y equals 2. So this is the point for y-intercept. So actually right now I just mark this is y-intercept and those 2 points are x-intercept. I just mark them like this. So x-intercept and y-intercept. Okay, so we mark our significant or critical points, critical for sketching the graph. And what we're gonna do right now, we need to find the minimum or the maximum value. In other words, we are going to find the vertex of the parabola. So this minimum or maximum point is called vertex. So that's why we go straight away. And condition to find the vertex is simply to say, so part number 3, finding vertex. So how to find the vertex of the parabola? We just simply can use the formula for the x vertex as minus b over 2a. Just remember, we have general form ax squared plus bx plus c. In our form for our function, sort of private case, that what actually we're given. So x squared plus 3x and plus 2. So what we need to calculate, x coordinate of the vertex minus b over 2a. So x vertex is simply negative 3 over 2. Okay? Or negative 1.5. And now what I'm going to do, this is only x vertex, but we need to find also y vertex. So y vertex. To find y vertex, we need to put in our equation your value negative 1.5. Okay, so just plug x vertex into your equation right there. And right now you understand this is y from minus 1.5. So, but I prefer to use fraction minus 3 over 2. And that what you need to plug instead of x here and x there. So let's try to do it right now. Just simply plug that and let's calculate what you will have finally. So negative 3 over 2 squared is a positive number finally, so it's 9 over 4. On top of that, we add 3 times negative value, so we will have negative 9 over 2 and plus 2 finally. So if you like, you can use calculator, but I'll try to calculate without it. So I've got 9 over 4 minus 9 over 2. You'll get minus 9 over 4 according to how you add in those two fractions, right? So common denominator is 4. So, and we'll get minus 18 and 9 here, okay? So that's how it works. So basically 2 goes here, and that's why it becomes negative 18. So finally you'll get negative 9 over 4. On top of that, you need to add 2, okay? So if you simplify that, you'll get finally the result for y vertex, which is, again, 2 you can present as the fraction, and you'll get 8 over 4, because 8 over 4 will give you 2, and finally it's negative 1 over 4. Okay, denominator is the same, so negative 1 over 4. So y vertex is actually negative 1 over 4 or negative 0.25 if you like. And x vertex that we recently found is negative 3 over 2, or negative 1.5. So that's why we found the vertex coordinates. I just fixed them up here, negative 1.5 and negative 0.25. And now let's just put this point on the graph. So this value we just set here. Okay, so what I'm gonna do, let me try to copy that. Here we go. I think it should work right now. So we just go down, yes, and we copy that. And now past this one. Yeah, finally works. Finally, I found how to do this. A little bit weird way, but okay. At least it works. Now let's go and put this vertex coordinate here. So negative 1.5, that's for x. It's exactly in between two x-intercepts. Sorry, my bad. I found that it actually should be not y. I don't know for which reason I put y. That definitely misprint. Sorry for that. Let me put it right here. So it's going to be, of course, x-intercept. Sorry guys, it just misprint. So this is also x-intercept. Okay. And also I need to fix this problem right here. So this is not y-intercept, but x-intercept, sorry. Okay, we fixed this problem. If you notice it early, it's good. So this point as the vertex negative 1.5, so it's in between. So this value is negative 1.5, and I actually write this. Here we go. And negative 0.25, so negative quarter, is somewhere here. So very, very close to, very close to the x-axis. So we've got the vertex point is right there, and this is the vertex with coordinates negative 1.5 and negative quarter or negative 0.25. So we set up the vertex, also marked as that, and actually it's ready to go. We can drop parabola, but before doing that, that's actually 4 points. So 2 x-intercept, 1 vertex, and 1 y-intercept. But before we're doing that, I prefer to use their line of symmetry. So it's going to be the vertical line, which goes through the vertex point and vertically. So it means it should go like this. So this is actually the line of the symmetry. And this is what you definitely need to know. So I just mark as the line. So I'll write here. So this is the line of the symmetry. Line of the symmetry. Okay. So in many questions, you need to be asked to write an equation for that. But make sure you understand that the equation of the line is simply for the vertical line is x equals to x vertex. So equation for the line of the symmetry is simply x equals x vertex. In our case is negative 1.5. Okay, so this is the equation of the line. Okay, and now, so if you are not supposed to drop the table, normally for the parabola, you need also to, starting from the x vertex coordinates, you need to expand your range for x values to the right and to the left. So you need to create the table of data or data set. So set up x value, pick up random values, like normally integers, plug into equation that you have and calculate y values. And so hence you'll get the points from that data set. But I'm not going to do that. Make sure you understand what actually you need to do in order to get more precise function. Just simply, I show you the sketch of the graph and I choose which color to choose. So I choose yellow color and draw up the branches for our parabola. So here and here. Make sure your graph should look like more or less symmetrical around this vertical line of the symmetry. So this is a parabola with the function determined by our equation x squared plus 3x plus 2. As you noticed, so now let's do some more advanced analysis a little bit. So as you notice, your x vertex coordinate negative 1.5 is actually exactly in between both x-intercepts points. So remember, let's remember before we found x-intercepts and they're negative, where is that? Negative 1 and negative 2. So on the graph you can also observe those values, negative 1 here and negative 2. So your negative 1.5 as the x-vertex value exactly in as the middle point of this segment from -1 to -2. So that's why you can use the shortcut instead of, if you forget to use the formula minus b over t that we actually use here. So you can use arithmetic mean. So this is arithmetic mean. So you can use x-intercept 1 plus x-intercept 2 and over 2. If you plug those values, you'll get negative 2, negative 1 over 2, negative 3 over 2. That's what exactly you get using arithmetic mean. So that's another shortcut. Okay. So that's why, for example, in questions like if you are given x-vertex coordinates and you're given one x-intercept, you can find another x-intercept using this formula. So that's why I just simply write that x-vertex is the arithmetic mean of x1, x2 over 2. Basically the mean point of the segment. But for y, you cannot do the same, right? So for y, you definitely need to plug your x-vertex into the function. That's how you can figure out y-coordinate for vertex, okay? So that's how we explored the function, and this is the general path. How you need to, which sort of analysis you need to provide in order to get the sketch of the parabola. We didn't touch the vertex form, that's for the next part, but I hope that those basics are very significant in order to get the proper graph. And here we actually recap several ways of solving quadratic equation, several ways of finding vertex coordinates, right, through the mean or through the formula. And we discuss how to find y-intercept. It was pretty easy. Just plug an x value into your equation, and finally we actually drop the graph. So one more observation that finally we can make is that coefficient. So in the equation y equals a squared plus bx plus c, there was coefficient a, which in our case is positive, right? And this is, in our case, a is 1 because we had an equation x squared plus 3x plus 2. And we have the parabola with branches up. So what we can notice that in our case, for this sort of parabola, coefficient a should be more than 0. So definitely for this parabola with the branches up, we need to have leading coefficients called leading coefficient. So leading coefficient, it's positive, so that's why branches up. If it's going to be negative in this case, we will have branches down, and that's why your vertex here becomes the minimum value, while in that case, it becomes the maximum value. Make sure you understand this, okay? So leading coefficient. And one more observation that's also very useful. Remember, we found that y-intercept is 2. Y-intercept is 2. So we use the condition x equals 0. But hold on. This 2 is actually when you plug in x equals 0 into the equation, you just basically cancel those terms because they're definitely 0, x squared and 3x, and you're left always with the last coefficient. So coefficient c. So that's why in general, coefficient c here is simply responsible for y-intercept. This is one more observation that you can notice from our analysis and our roadmap that I drew up here. Okay, so guys, one more time, recap. Just make sure you understand those steps, and that's how the analysis, in order to sketch the graph, in order to say where branches up or down, where the y-intercept, where the x-intercept actually can be provided. So this is the basic analysis. So it's not really advanced because we didn't touch transformation and we didn't touch the vertex form. So that's, I think, the topic for the following part 2 for the crash course of the quadratic functions. So hope you like that. Make sure you got all those steps. I tried to explain with depth and different ways to describe that. So hope you like that. If you're new here, please subscribe. If you actually want to be notified about updates on a daily basis, so please smash the bell button and just share in comments which video and which topics you would like to see in the nearest future, and I'll try to create upon your request, guys. So you're always welcome, everyone, every single subscriber, every visitor. Please just try to use my resource. I think they will be useful for you, and that might work for like different aspects of your development in maths. Okay, make sure also you check the A-level stuff. I just started mechanics, so if you want to have A-level maths powerful preparations, so I can share with you guys my friend, so it's from New Zealand, so Zealand's A-level class. So please make sure you find it on YouTube, and also please subscribe. Just try to use his resource. It's quite like awesome person who actually explain in depth, in details. So please, you're also welcome there. That was Daniel Dallas. Thank you guys, and see you later.